Today, I would like to talk about one of the open problems in mathematics. And if you can solve this problem, you would win a prize money of $1 million. The problem statement comes in the form of conjecture, and this particular problem statement is called Beal's conjecture. First, we need to understand what a conjecture is. Conjecture is nothing but it is a conclusion that is postulated without a proof. Let me try to explain what a conjecture is outside of mathematics world or in layman terms. Okay. So I'm going to state a conjecture telling that between 1 and 2 p.m. only red cars drive in front of my house. This is the conjecture. Now, this is said without proof. This conjecture can be proved or it can be disproved. To prove this particular conjecture, what I can say is I can prove that if I can prove that all cars in this world are red, then this becomes true statement. Right? The conclusion what I made is right. Now, one way to disprove this conjecture is by, let's say, I take a video of a blue car driving in front of my home between 1 and 2 p.m. Now, I have made this statement as false. Whether it is proved or disproved, we have found the conclusion is right or wrong, which in turn we have actually solved this conjecture. Right? So hope you got an idea of what a conjecture is. Now let us look into what is a Beal's conjecture, and we can also look into these two states of being proved or disproved. This is also one of the interesting conjecture because of the status of who proposed this conjecture. So it was proposed by Beal, and the interesting part is he was considered as an amateur mathematician. and it was proposed in the year around 1993 approximately. And imagine this, like a lot of mathematicians have tried to work on this problem and they are not able to solve this particular conjecture. And so this is what it makes easy, and of course you can, if you can solve this, you can win 1 million US dollars. Okay, so let us look into the conjecture now. Now the conjecture, for the conjecture, what the conclusion what he made is as follows. Consider the following equation. Okay, a power x plus b power y equal to c power z. Now apply the following conditions. A, comma, B, comma, C, and X, Y, and Z. They all need to be a positive integer. Positive integers, okay. And another condition is x, comma, y, comma, z should be greater than 2. So it means that it can be 3, 4, 5, and so on, but it cannot involve 1 or 2. Then what Beal proposed or has come to the conclusion is the result. This is the result, the proposed result is that A, comma, B, comma, C will have a common prime factor. By prime factor, what I mean is that when A divided by a number n and B is divided by a number n and C divided by a number n, and they don't leave any reminders, so it is exactly divisible. B is exactly divisible by 9 and C is exactly divisible by 9. N is a prime. As simple as that. Right? So some of the cases for this might be, let's say we have 2, 4, 6, and all these numbers are actually divisible by 2. Right? So this is an example of A, B, C. And now we can look into how some of the solutions of this particular equation, and if there are any counter examples for this particular equation. Now to look into this particular equation, let's try to create a table for simplicity. So we have A, x, then we can do a power x, b, y, we can do b power y, then we can do c, z, and c power y. So let's take here, it's a very simple example. Let's do 2, right? And x can not be 2, it needs to be at least greater than 2, because if we do 2x, y, and z, it becomes Pythagoras theorem, which is already proven. So here we need to have, like, let's do 3, right? And 2 power 3 is nothing but 4 4 2s are 8. Okay, and now b power b, let's do again 2, and it is totally fine to have x equal to y. Then let's do another 3 here, and again we have 2 power 3, which is equal to 8. Now c is actually c power z, so let me rewrite this particular one in a different way. So what we are having is, let's do a power x plus b power y, right? And that will be c power z. And then we can do what is c and what is z. So in this case, it's going to be 8 plus 8, which is nothing but 16, and where c can be written as 2 power, and z can be written as 4, or 16 can be written as 2 power 4. As you can see, we have a power x, which is nothing but 2 power 3, and we have b power y, which is nothing but 2 power 3, equal to, we have 16, which is nothing but 2 power 4. Now, as the conjecture says, we need to look into a, b, and c. So a is nothing but 2 comma 2 comma 2, which is a, b, and c. As you can see here, the numbers a, b, and c has a common divisor, which is a 2, and 2 is a prime number. And this is a very basic example of, where this particular equation is true. Right? Now let's look into another example. True examples or true solutions. Right? Three power 3 plus 6 power 3 equal to 3 power 5. So if we calculate 3 power 3 plus 6 power 3, we get the value of 3 power 5. So here again we have 3, let's do a, b, c, 3, and we have 6, and we have 3. Again, the common divisor for all these things can be divided by 3. Another equation is 7 power 3 plus 7 power 4 equal to 14 power 3. Right? And now again we have 7 comma 7 plus 14. All these are divided by 7, and 7 is a prime number. Right? And of course, there are lot of programs and computer programs which people have looked into right from 1993, right? And all they were able to find, the answers were always the true solutions showed up. How much ever the big the number is, always the true solutions showed up. And whenever a solution showed up, A, B, C, or these terms were always had a common prime divisor. And that is the interesting part, right? Like, imagine a equation of such simplicity, right? And whatever the divisor is, all these numbers are actually divided by a prime number. Now, proving is very difficult because you need to make sure this particular solution set will be available in the entire universe or in the math universe. Now, for false statements, people have looked into disproving it, right? So if you can find something like, let's say, 8 and 15 and 4, right? If you can find something, there is no common divisor between these things, no prime except for one, obviously, right? So but one doesn't count, because what we need is a prime number, right? If you can find where 8 is equal to A, B, and C, that means you have won $1 million. And people have looked into multiple numbers, big numbers, still they are not able to find it. I hope this conjecture was interesting for you. Thank you for watching and have a wonderful time ahead.